My name is Avilay. I'm a machine learning engineer based out of Seattle. And in this three-part mini-series, we will cover backpropagation. So what is backpropagation anyway? It's an algorithm to calculate the derivatives of variables in an equation. So put very simply, given a function f of x, it will output the gradient of x. So if y equals f of x, then it will output dy dx. And of course, if f is a function of multiple variables, then it will output the partial derivative of y with respect to x and so on, but you get the idea. And most of us have learned techniques like the chain rule or the product rule to compute derivatives by hand. But these become really tedious when we apply them to multidimensional tensors and very complicated equations. And those are the kind of equations we see in neural nets. But this is where backpropagation really shines. It takes the tedium out of it and makes it tractable to compute the derivatives of such equations. So what we'll cover in this three-part series is in the first one, we will understand compute graphs, which are a fundamental building block for backpropagation algorithms. In the second video, we will actually hand draw the backpropagation of a simple equation. And then we will see that using PyTorch APIs, it becomes so much more easy. And in the third video, we will do the same thing, but with a little bit more of a complicated equation. And the objective of this entire series is that given any equation, you're able to apply the backpropagation algorithm and compute the gradients of that equation, regardless of how complicated that equation may be. So with that, let's get started with our first video. I'll see you there.